Hello students, once again welcome to the LJ Institute of Engineering and Technology. Let's start with the course Mathematics 1. Today's chapter is Application of Partial Derivative, and in this chapter today's topic is tangent plane and normal line. So let's start with the basic concept of tangent plane and normal line. Let capital P be any point on the surface f of x comma y comma z is equal to 0, or we can write z is equal to f of x comma y, and q be any other point on it. Now take any curve on the surface joining q to P. As q tends to P along this curve, then the PQ tends to define a straight line, and that straight line is called tangent line to the surface at point P. Same way, we can find a different curve can be obtained by joining different Q to P, and different tangent line are obtained at P, and collection of all these tangent lines lie in a same plane called tangent plane to the surface at point P. For example, if I say this is one plane, this is sphere, that means ball. If I have a ball like this lie here on the ground, and this is the one point of the ball, and if a plane passing through this point, one simple point, this plane is called tangent plane, and a point at which this tangent plane passing, if we take perpendicular line to that point, that perpendicular line is called normal line. Okay, so tangent plane, that means plane which is passes through only single point, this one. Okay, and this perpendicular line to this surface at point P, the perpendicular line is called normal line. Okay, so the equation of tangent plane is given by, at point P to the surface f of x comma y comma z is equal to 0, is given by x minus x0 into del f by del x at P plus y minus y0 at del f by del y at point P plus z minus z0 into del f by del z at point P is equal to 0. So you have to just find this three derivative at given point P, and P is the point on the surface, okay, from where that plane is passing. And similar way, the line through P perpendicular to the plane, as I told, perpendicular to the plane is called normal to the surface at point P. Same point P where the plane touches the surface. Okay, and the equation of normal line to the surface at point P are given by this equation. That means x minus x0 divided by this derivative, y minus y0 divided by this derivative, and z minus z0 divided by this derivative. Okay, these are these two equations of tangent plane and normal line. Okay, so how we will apply these two equations and how we can find tangent plane and normal line? Let's have a look on the example so you can understand better. First example, find the equation of tangent plane and normal line to this surface at point this. Okay, so let's start with the solution. First we write down the surface, and to write down surface, as I told, we have to write down f of x comma y comma z is equal to 0. That means we have to take each and every term to the left side, or we can take on the right hand side. Okay, now f is equal to this surface, and point P is given by this. So x0, y0, z0 will be 2, 1 and minus 3 respectively. So we will find the derivative with respect to x, y and z partially, and we will put the point P in that derivative we have del f by del x is 4x, differentiation of this, and differentiation of this and this term will be 0 because this is partial derivative. And at point P we have to put this entire point, but here only x is there, so we will put 2 only, so 4 to the 8. Similar, we can find del f by del y at point P, del f by del z at point P. So we have 8, 1 and 2 value. Now just write down the equation of tangent plane. So we have equation of tangent plane is given by this, as we have seen previously. So value of x0, y0 and z0 is 2, 1 and minus 3, and value of this derivative are 8, 1 and 2. So just we have to replace these values. So we have this equation is x0 is 2, y0 is 1 and z0 is minus 3. So this minus become plus, and value of this derivative 8, 1 and 2. By opening this bracket we have 8x minus 16, y minus 1 and 2z plus 6, and by simplifying 8x plus y plus 2z and taking this number together we will have minus 16 minus 1 minus 17 plus 6, which is minus 11. This is our final answer, and you can write this answer in this form also. Both are same. Okay, so this is our equation of tangent plane. Now we will find the equation of normal line, and we know the equation of normal line is given by this, as I told previously, x minus x0 divided by derivative at point P, same way for y and same for z. In between there is equal to. So pay attention here, this is equal, not plus. In tangent plane there was plus. Now we have to just put the value of x0, y0 and z0. Z0 is minus 3, so this minus become plus, and derivative 8, 1 and 2. This is our final answer, that means equation of normal lines. Okay, but if there is a question in examination, find parametric equation of normal line, then what? Then you have to do this step. That means we have to take this equal to t, that normal line we have already obtained here, which is equal to t. That means these three term equal to t. That means first term is equal to t, second term is equal to t, and third term is equal to t. If we take first term is equal to t and making x subject, so we have 8t plus 2. Similar way, second term is equal to t, y is equal to t plus 1, and z is equal to 2t minus 3. These are the parametric equation of normal line. Okay, so if in examination it is asked, then and only then we will do this step. Otherwise, no need to do this step. We will just stop here. Okay, this is our final answer if parametric equation is not asked in examination. Now one more example to understand better. We have this example, find equation of tangent plane, normal line to the surface this at point this. Same step, nothing different. Just you have to keep one thing in your mind, you have to make function from the given surface. F of x y z is equal to 2x square plus y square minus z square by taking to the right hand side, or you can take this two term to the left hand side. Answer will be same. You can check by using not and pen. And point P is given 1, 1, 3. And we know that find the derivative at point P, derivative with respect to y partially at point P, with respect to z partially at point P. Now write down the only formula, replace this value y0 and derivative z0 and derivative. We have this equation. By simplifying, by expanding this, we will get this. By collecting a variable together and this number, we have this equation, and by taking this minus 3 on the right hand side, or we can left here also, I am just taking, this is our equation of tangent plane. Now we have equation of normal line. So write down equation of normal line and put the value of x0, y0, z0 and these three derivative. We have this final answer. No need to write down or no need to obtain that parametric equation because there is no asked in question. Okay. Now one more example, and this example is quite different from previous two example. An example is show that the surface z is equal to xy minus 2 and x square plus y square plus z square is equal to 3 have same tangent plane. So here no need to find a normal line, only we have to find tangent plane for this surface at this point and this surface at this point, same point, and we have to show that both the equation are same. So let's start with the same process. First we will find f, so we will take z to the right hand side, so minus z point derivative 3 derivative at point, so we have 1 1 minus 1, point is also 1 1 minus 1, and write down the equation of tangent plane, put the value of this term, and by expanding this we will get the final answer x plus y minus z is equal to 3. We have to note down this equation, and now we'll start with the x square plus y square plus z square is equal to 3 at point this. Okay, so note down this. Noted? Okay, let's start with this equation. Then the surface f is equal to x square plus y square plus z square minus 3, because as I told, we can take on the left hand side or on the right hand side. Find three derivatives. At point P, we have this 2 2 minus 2 and equation of tangent plane. Write down the equation, put the values of these terms, and we have this. By expanding these three terms, we will have this equation. By taking 2 common from this and taking the right hand side, so 2 into 0 becomes 0, and we have this, and which is same as previous tangent plane. So we can say that surface this and this have the same tangent at given point. Okay, now one more example. This example is again little bit different from previous three example. So question is, so that the plane touches the surface this. Now here tangent this touches this plane surface, that means this is tangent plane. So you have to check this is the tangent plane touches the surface and find the contact point. That means by using this tangent plane we will find point and we will check if that point satisfy this both equation, this surface equation and this tangent equation, then we can say that this is the tangent of this. This is one of the tangent of this surface. So let's start with the first surface. There is no point, so we will take arbitrary point after getting this derivative del f by del x, del f by del y and del f by del z. Let p x0, y0, z0 be any point on the surface, because we know that this surface and tangent plane already given, but this plane is at any point, so that p, this is p. Okay, we will take this point x0, y0 and z0. So this is the point, so we can put in these three derivatives. So we have this three derivative at point P. So x is x0, y is y0 and z is z0, but here 2, so 2 as it is. Now by equation of tangent plane, we have this equation and we will put the value of this 6 values, but x0, y0, z0 is as it is, and the value of derivatives are 2x0, 6y0 and 2. So we have these three values. By expanding this bracket, 2x0 into x, so 2x0, x into x0, and x0 into 2x0 is 2x0 square. Now 6 y0 multiply with this y and multiply with this y0. Same way 2 multiply with this z and 2 multiply with this z0. Here you can observe that we can take 2 common from this equation, entire equation. So 2 cancel, 2 cancel, 2 cancel, then 3, 2 cancel, then 3, 2 cancel and 2 cancel. Now as we have said that this is the point on the surface and surface is this, so this point x0 y0 z0 satisfy this surface. So surface becomes x0 square plus 3y0 square plus 2z0 is equal to 0. Now we can put the value of minus x0 square minus 3y0 square, because these are in linear equation, in addition. So if we take a right hand side in this equation, so it become minus and this become minus, and we can replace this minus this by 2z0. So this is plus 2z0 and this minus z0 gives plus z0. So x0 as it is, 3y into y0 as it is, this z as it is, and these two term together gives 2z0 plus, and this minus z0, so plus 2z0 minus z0 gives plus z0. Now this is our tangent plane, equation of tangent plane, and one equation is given. So we will compare that obtained tangent plane with given tangent plane. So compare with this given tangent plane and this is obtained. So this divided by this, x cancel, so we will get x0 by 4. Same way this term divided by this minus 6y, y cancel, we will get 3y0 divided by minus 6. Same way z divided by minus z, so 1 upon minus 1, and z0 divided by 14, this one. Now by equating this term with this term with this, and this term with this, we will get the value of x0, y0 and z0. So this term is equal to 1. So x0 divided by 4 is equal to 1 upon minus 1. So x0 will be minus 4. Same way we'll get y0 and z0. Okay, got it? X0 is minus 4. Then after using this 2, we'll get y0 is 2. And after using this 2, this term, z0 is equal to minus 14. So this is our contact point, and we will check is this point that minus 4 to minus 14, let me remove this, satisfy the equation of surface which is given in question and tangent plane which is also given in question and which is here. So if we put this point in this equation, we will get 0. Same way, if we put this point to the surface which is all given in question, which is also satisfied, and that's why this is our contact point, and this given plane gives the tangent plane. Okay, so this is our contact point. So how this example is different from other 3 examples, you have to keep in your mind, pay more attention, keep rewinding and see again and again what are the changes than that previous example. Okay, and these are the DIY that you have to do yourself one by one. Simple example. First example only tangent plane normal line. Second example is same as previous, that you have to show that given plane touches the surface and find contact point. Same way, third example is simple as example number 1, and fourth example is as example number 2. These are the practice example. Do it yourself. Okay, so thank you for watching this video. Keep watching, keep learning. Always use pen and pencil. Thank you.